All right, so here's what you're gonna need for this lab. I've got some scissors. You could probably get away with not using scissors, but you should probably have some scissors. You should have some pipe cleaners. If you do not have any pipe cleaners, then please ask me or Mr. Tout for some. But you should have received some in your package if you requested some earlier in the year. You should have a ruler of some sort. This is the ruler that I was giving people. We have more of these. So this is just like 6 inches, but if you have measuring tape, then that is ideal. But the 6-inch ruler will do just fine. Let's put that over there. I have some tissue paper. You can also use a coffee filter, large coffee filter. The bigger the better, the more air that you're going to capture with your Skydiver. So what we're going to do is with our pipe cleaners, and you can use more than 2 if you want to, but however many pipe cleaners you use is going to be the mass of your Skydiver, because we're going to make a Skydiver out of these guys, right? So what we're going to do is we can make a head for our little Skydiver guy, all right? So there we go, there's my guy's head. And then what I'm going to do is, let's see, you can be as creative as you want to be with this step. You can see that clearly I am very practiced at making my coffee filter Skydivers here, but you can have a go at making some legs, right? Notice he's got a large head. This is actually kind of necessary for the whole design here. And then if you want, you could even snip one of your pipe cleaners. All right, they shouldn't be too hard to cut. And give him some arms because he needs to be able to wave his arms as he is falling through the sky, or she, or them, doesn't matter. All right, very bright colors going on. There is our coffee filter Skydiver. Cute, huh? Okay, so now that we've got our coffee filter Skydiver, we need to attach Mr. or Ms. Skydiver to the parachute. And that's where the string comes in. So you also need some string. Again, these are all materials that we have available for you if you need some. So I highly recommend cutting out 4 equal lengths of string. And I've got 4 evenly long pieces of string or thread. Thread would actually be really light. You could do that too. And then what we're going to want to do is we're going to want to make sure that all of these are attached to the Skydiver, right? Doesn't need to be super tight. All right, so now I have all 4 attached to the Skydiver's head. Now is the somewhat tricky part, right? So now is where I need to have holes in my coffee filter or my tissue paper so that really what I'm shooting for, and notice how this isn't even a circle. It could be a circle. All right, I'm just trying to show that it doesn't have to be perfect. But I'm going to aim for attaching them in these 4 points. All right, attaching each one of these strings at each one of those points. So the tricky part to this is that you do not want to rip the tissue paper or the coffee filter. You can use the tip of the scissors, give yourself a hole, and then loop the string or thread or yarn, whatever you have, through that hole and gently make a knot in order to hold it. Just want to make sure you do them all the same way. The consistency is really what's key here. And so now I have my coffee filter Skydiver attached to their parachute. And we can see that the parachute's already grabbing some air, which is exactly what we want. So, and if any of these holes that you made, if they're not working out for you for whatever reason, you can always take some tape. If it rips off, you can take some tape and just tape it on. So that's an alternative as well. It's just not necessarily going to hold as well. Just be gentle with your coffee filter Skydiver at first. And now we're going to launch him. All right, so next step is we want to take a few test flights just to see how this works. All right, so first test flight I'm going to take, I'm just going to hold it by the parachute and let it go. And we see that it floats to the ground. It kind of floated out of view for you guys here. Hold it to the top and it floats to the ground. So what's happening here, just to describe this motion real quick, is that at first the Skydiver accelerates, okay? Because right now the Skydiver has a velocity of 0 meters per second down. As soon as I release it, the Skydiver accelerates and eventually stops accelerating, arriving at a constant velocity. So when the Skydiver is just floating down, that is a constant velocity. It has reached what we call terminal velocity. When the velocity of the Skydiver isn't changing, right? Doesn't mean it's not moving, just means it's not changing. Then it's reached terminal velocity. And remember, the force, air resistance is pushing up, gravity is pulling down, and you have these equal and opposite forces, and that means you have 0 acceleration, right? Equal and opposite forces means that it's just traveling down at this constant rate. So my challenge to you is to measure 2 things. I'm going to give you the more important one first. It's going to be out of order, but I'm going to give you the more important one first. The more important thing that you measure in this experiment is the velocity, that terminal velocity, right? Whatever velocity it's going at when it stops accelerating, which is pretty immediate, right? If I release it, it almost immediately accelerates to that terminal velocity right about here, and then just floats the rest of the way down. Well, how do we calculate velocity? Velocity equals distance over time, right? So since velocity equals distance over time, we need a distance and we need a time. Well, turns out, should have a ruler, a meter stick, or a measuring tape of some sort. And what I want you to do is I want you to measure to a certain point along a wall. If there's already a marking on a wall that you can use, I don't want you to mark your walls, all right? If there's something that you can use as a guideline, figure out what that distance is. Ideally in centimeters or in meters, but inches are fine. So I'm going to show you an example of this. I've got some masking tape here that I can use to mark the wall. Masking tape is perfect because it's meant to come off of walls. Just don't stick it too much. So there is my mark on the wall. And the reason I put the mark there is I've noticed by releasing my Skydiver that by the time, and I'm going to judge by the parachute, by the time the parachute gets to this mark, it's hit terminal velocity. It's not accelerating anymore, right? I might even be able to put that mark up higher because I can see that it doesn't take very much time for it to accelerate at all. So I release it. All right, it's definitely going a constant velocity by the time it's here. Why is that important? Well, I want to make sure that for the time that I'm actually keeping track of how long it takes to go from here to the ground, that it's going a constant velocity. So, and you can just eyeball this. So It's going a constant velocity from this mark down to the ground. So that means what I need to do is I need to measure what distance that is from here to the ground. And then I'll time it. I'm not going to show myself timing it. We know how to time trials. Do it at least 3 times, right? And so when you start, then it hits the ground, stop. Okay. Again, start, hits the ground, stop. You should keep track of what this distance is. The parachute isn't going to be on the ground when it hits the ground, right? When the skydiver hits the ground, the parachute's going to be above. So you're going to need to figure out what that distance is, right? So if the skydiver is hitting the ground right here, I'm going to measure this distance from this mark down to where the parachute is. There's going to be a little estimation in here. So your significant figures, you're not going to say like 34.2 inches. There's no way you could tell 0.2 inches. In fact, I debate with you at the 34. It's probably you're going to be able to say like, oh, it was about 30 or maybe 35 or maybe 45 inches. Okay, so the distance is from the mark to wherever the parachute is when the skydiver hits the floor, right? And do that 3 times. So that's the first thing I want you to do. That's the first challenge. The second challenge you don't have to do, but I want you to think about how you could do it and try to collect some data. Okay, so the second challenge is acceleration. Can you determine how fast this skydiver is accelerating before it hits terminal velocity? The tricky part to this, there's a lot of tricky parts to this. What do you need? What information are you going to need? You're going to need to know the distance that it takes from the beginning to when it stops accelerating. You're also going to need to know the time that it takes in order to do that. Once you have that, then you're fine. But you're going to need that distance and that time. It sounds like velocity, okay? But you're going to need to know what that distance is that it accelerates in and how much time it takes as it's doing that. So here's the trick, is that in order to do this, you're probably going to want to toss the whole thing in the air and then let the parachute open up. It didn't open up that time. You're going to have to practice. This is why it's tricky. Toss the whole thing up in the air and then hope at some point that you get it so that the parachute opens up. Almost did it that time. And that you time how long it's accelerating for. And again, this is tricky. It's optional. It's something that it's a challenge, right? And see if you can figure out the distance that it took to accelerate and how much time it took to accelerate. All right, I hope that's clear. I hope you understand what you're going to be doing. Again, I just want 3 trials of wherever your mark is, how long as long as the skydiver is traveling at a constant velocity. I just want the 3 trials from that point down to where it hits the floor. Make sure you get that distance, make sure you get that time. If you get it in inches, it's fine. Shoot for centimeters if you can get it, but inches is fine. Any questions, please let me know. Please let Mr. Tout know if you're watching this in his classroom, and I'll see you online.